Good morning, this is Mr. Spinasay, your stat sensei, and we're going to go through a bunch of definitions that are really important for regression. We've laid out some templates for you that I think will help you out. You kind of need to memorize these. Actually, you don't kind of, you need to memorize these. It will take some time, so the more time you spend writing them, the more it'll help. I'm going to quickly go through them definitionally or laying them out, and then we're going to put them into action so you can actually see how they work. So slope. Well, basically in Algebra 1, you learn slope is y over x, and technically it's the change in y over change in x. In case you didn't remember, the triangle represents change. So we end up calculating a slope, and whatever our slope is, the expected amount of change in our y value for a 1 unit change in x, all right? Our slope intercept, or our y-intercept, this is basically where it crosses the y-axis. So this is where it crosses the y-axis. The amount of y that you begin with or would have if the amount of x equals 0. Our correlation coefficients, which tells how strong the linear relationship is. By the way, a correlation R equals the square root of R squared. And we'll talk about R squared in just a moment. And if the absolute value is greater than 0.75, so if our R is 0.75 or 0.85 or 0.95, or if it's negative 0.85 or negative 0.95, there is a strong, then you need to include the sign. If it's positive, a positive linear relationship. If it's negative, a negative linear relationship between whatever y is and whatever x is, all right? Whatever the name of our y variable is and whatever name our x variable is. If you swap the order on these two, it's okay. So you can swap the order here and it's not a big deal. If it falls between, if the absolute value of r falls between 0.4 and 0.75, there's a moderately strong, and once again, always make sure you include the direction, whether it's positive or negative, between our y and our x, whatever those definitions of y and x are. And of course, if it's less than 0.4, there's a weak, and then once again, you need to give the direction, whether it's positive or negative linear relationship between y and x. R squared, that is known as the coefficient of determination. Super important concept. And basically, they'll give you some decimal value, and R squared is always positive, and it'll always be between 0 and 1. And so let's just say it's 80%. So 80% of the variation in whatever our y variable can be explained by changes in whatever our x variable is. All right, real important on this one. S is the standard deviation of residuals, and they'll give you some value, whatever that value is, and measures the variance in whatever y is for a specific amount or a given amount of x. The long one, the standard error of the slope. The standard error of the slope is, and this will be some calculated value that they will give you, because the slope is estimated from the sample, other samples are likely to have different slopes. The standard error of the slope quantifies the amount of variation in the sample slopes that can be expected. So in other words, you may have calculated a slope that looked like this, but because you know it came from a sample, maybe your slope really goes like this, or maybe it really goes like this. And the standard error just tells you how much that slope may vary by. So let's put most of these in action. We're not going to put all of them in action, but we're going to put most of these in action. Well, we're going to go back to our favorite airfare problem. And once again, this data was initially on page 246 of your notes file, but here it is again. All right. And you're going to need to input all that data into stat edit. And so we have an L1 and to L2. So I've input all the data in, and I've checked to make sure that I got these values. And X, well, X is our distance, and basically X is the distance traveled in miles. Great. By the way, a lot of times they'll ask you to actually define these variables, so you need to be used to doing that. Y is the fare charged in dollars for a given trip. all right? Then it says write the equation of the linear model. Really important, this is a y hat. This is the y hat because it came from the sample. And you're like, well, how did we get that equation? Well, we kind of did that earlier, but we did it very fast and we actually didn't write it down at that time. We're going to go to stat calc. We're going to drop over to number 8. And by the way, I should go back and show you that stat calc. I'm going to drop down to number 8, which is linear regression. My X list is an L1. My Y list is an L2. Make sure you always store the equation by going alpha followed by trace. And we ended up getting an alpha value of 1.7721. That's my y-intercept, and my slope is 0.0786. So 1.721, my y-intercept, and my slope of 0.0786x. All right? So we calculated the slope, and it says find the slope of the regression line and explain what it means in the context. Well, our slope is, and by the way, you really need to label it like this. So always $0.0786, and it's 1 mile. So for every 1 mile increase in distance, there's a 0.0786 increase in fare. All right, and basically that's coming from our equation. All right. So we have an expected amount of change of $0.0786 for every 1 mile change in fare. Find the y-intercept and explain what it means. In this case, it's 177.21. We would expect our fare to be 177.21, and really I should say that this is dollars. And you can use a dollar sign. If we boarded the plane and flew a total of 0 miles. All right, well, what does that actually mean? All right, what does that actually mean? What that actually means in this case is that they probably are covering maintenance and of the plane and just having the plane and things of that nature. And just to cover those costs is $177.21. But for our definition, we're going to say this would be the airfare if we flew 0 miles. I'm going to pause this for just a moment. Okay, we're going to move on to calculating S. I'm just going to let you know that I've never seen them have you do this, but let's just say they ask you to do it. So here's what you're going to do. You're going to go to stat, arrow over to the word test. We're actually going, so we're in test now, and we're going to scroll down till we get to linear regression t-test, which is F. So linear regression t-test. My X list is an L1. My Y list is an L2. We're going to go ahead and use a not equal to 0. We'll talk about that later. I'm going to store my regression equation. So alpha trace, enter. And I'm going to ask it to calculate. Well, it's giving me a bunch of information. There's my y-intercept. There's my slope. And there's my S, 41.82. Now, the majority of time, I've never seen them ask this. So they will give you this most of the time. And they'll say the standard deviation of the residuals is 41.82 and measures the variance in airfare for a given distance traveled. All right. So basically the standard deviation in airfare for a given distance traveled. So we're going to go back to R and we're going to go to stat test, scroll down, stat calc, excuse me, number 8, alpha trace. And there's my R, 0.7, and apparently I have a data entry error. But so I don't think I don't believe that was my R value. I believe 0.694 is. Let me go back and check that real quickly. Stat. Calc. Oops. Stat calc. Linear regression. Oops, that's what my problem is. Second one. alpha trace. There we go, 0.694. So there's a moderately strong, because this falls into that category of being between 0.40 and 0.75. There's a moderately strong positive, always need to give the direction. If it had been negative, we'd say negative. Linear relationship between airfare and distance travel. They also gave us R squared, but really R squared is just 0.694 squared. All right. So if I take the 0.694 and square it, I'm going to get that value. So 48.2% of the variation in airfare can be explained by changes in distance traveled. Well, that makes sense. The farther you fly, the more you expect it to cost. But there are other things that impact it, which is why it's not 100%. Sometimes the destination, time of day, the accommodations on the plane, all those things, in who the airline is, how popular the destination is, et cetera, impact the price. So consequently, we only explain 48% by distance, and about 51 or 52% is explained by other things. Estimate the airfare for a 750-mile flight. Well, here's what our equation was, and we just plug in 750, and we say, oh, we expect it to cost $236.18. And all we did, real simply, was 177.21 plus 0.0786 times 750. All right, now I wrote 18 cents, that's rounding error, okay? Estimate the airfare for a 392-mile flight. Well, it's the same thing, 177.21 plus 0.0786 times 392. And we get $208.02. Then it says calculate the residual. Well, remember, residual is y minus y hat, or observed minus expected. Well, we calculated the expected up here as $208.03. That's what we expected to be. But we actually had a 392-mile flight, and we need to figure out what it actually cost. So when we flew to Orlando, we had a 392-mile flight, and it cost $238. So that was our observed. So this is why we have 238. And remember, this is y minus y hat. All right, y minus y hat. Observed minus expected, actual minus what we predicted, because this is what we predicted. But what really happened was this. So we subtract the difference and we find out that our residual, so our R in this case, is 29.7. Okay, so that's real quickly going through a bunch of definitions. We're going to have a lot more practice with that, but hopefully that will help you get started. I'll see you in the next video where we work on computer printouts for regression. Once again, this is your Stats Sensei, and I'll see you on the next one.